All right, now we're going to get some derivatives for exponentials and logs. And we're going to derive those using the definition of derivatives for starters, but then we'll move from there just like we did with the trig functions. So the first thing we need to do is we need to remember about this number e. Remember, this is the definition of the number e. It's the limit as x goes to infinity of this function, and it's approximately 2.7182, blah, 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 blah. So we have this number e, and it's kind of our basic exponential function. Because remember, an exponential function is a number raised to a variable power. So if we want to find the derivative of our basic exponential function, e to the x, first we're going to have to look at this limit here so that we'll be able to derive that. Now the way to do that is with our graph. So on your calculator, if you want to graph this function, it looks like this. And we want the limit as our x values approach 0, so right in here. Now if you recall, the easiest way to find that is with the table. So if you set up your table so that you're looking right around 0, you'll see that yes, we have a 0 there. That doesn't work. But as we get closer and closer to 0 from both sides, we're getting closer and closer to 1. And that means that our limit for this particular function is 1. Now why do we need that? Well, when we want to derive our derivative of we want to find out what the derivative of the basic exponential function e to the x is. Remember, the definition of a derivative is the limit as h goes to 0 of f at x plus h minus f at x all over h. So we take the limit as h goes to 0 of e to the x plus h minus e to the x over h, and now we need to simplify. Well, remember, if we have e to the x plus h, that's the same thing as e to the x times e to the h. So we're going to use that and say the limit as h goes to 0, and we'll factor out that e to the x, and we're left with our e to the h minus 1 over h. Make sure you understand how we got that and why that works. And then we can split it up. We have the limit as h goes to 0 of e to the x times the limit as h goes to 0 of e to the h minus 1 over h. And now you see why we needed that limit. So we know this one is 1. And this one here, there's no h in that, so it's just e to the x. So what you see is that the derivative of e to the x is just itself. Now if we have a more complex exponent here, we can use our chain rule, and we see that it's the derivative of the outside part times the derivative of the inside part. So this is one of those add to your spiral to be studying. So now that we have that, we can use that to derive, to find the derivatives of other exponentials and even the logs. So what if we have a more general exponential, a to the x? Now remember, we have always used a's greater than 0 and not equal to 1 when we've done this. So let's think about how we can relate these two. Well, a to the x is the same thing as e to the x times the natural log of a. Now, go ahead, calculate that out. Make sure you understand by all those log properties why that's true. Okay, because if we take this, remember this exponent goes up here, so it's e to the natural log of a to the x power. You know that you have, if you take the natural log of both sides, then you'll end up getting the natural log of a to the x equals the natural log of e times the natural log of a to the x. You know the natural log of e is 1, and derive that. If you are having trouble remembering that this is true, pause the video and write it out in your notes until you've got it and make sure you know it. But by all the log properties, this is true. So if we're taking the derivative of a to the x, then what we're doing is we're taking the derivative of e to the x times the natural log of a. So we know that the derivative of e to the u is just e to the u times the derivative of the u. Well, the natural log of a is just a number. So if you have a number times x, then the derivative of that is just that number. So since we know that this is a to the x, the derivative of a to the x is just a to the x times the natural log of a. If you have to do that with a more general, then the derivative, we just use our chain rule again. It's a to the u times the natural log of a times du dx. Take that derivative of the outside times the derivative of the inside part. So there's another one for your spiral. Okay, so for an exponential, it's just that exponential repeated times the natural log of whatever the base is for the exponent, times the derivative of the inside, the exponent part. Now, what about if we have the natural log? Well, if we can rearrange this into exponential form, we get this, and we can use our implicit differentiation to be able to find the derivative. So we take the derivative of this side, which the derivative of e to the u is just e to the u times du dx. So instead of u here we have y, but same type thing. What's the derivative of x? Just 1. So the derivative is 1 over e to the y. Well, what's y? Y is the natural log of x. So we have 1 over e to the natural log of x, and you know from all your exponential and log properties that it's just 1 over x. So the derivative of the natural log of x is 1 over whatever you're taking the natural log of. Of course, again, if we have something more general, where we have to use our chain rule, we just do that. 1 over whatever you're taking the natural log of times the derivative of that stuff. So here's your other one. Now, what if we have a more general log? Well, nowadays we don't use those nearly as much, but we're going to go ahead and look at it just to make sure you've got it. If we've got y equals log base a of x, you know by your change of base form that that's the natural log of x over the natural log of a. So if we want to take the derivative of log base a of x, we're really taking the derivative of the natural log of x over the natural log of a. So here we use our quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom. Remember, natural log of a is just a number all over the bottom squared. And then we can simplify that. And we just get that we have 1 over x times the natural log of a. Write this out if you need to, pause it, and make sure you know how we got here. So then if we use our general form, if we have to use our chain rule, we just have to take that derivative of the inside part into consideration. So if we have the log base a of u, then this is our general form. Now, if you notice, if your a is e, which is the natural log, which we just did, if you plug that in, you're taking the natural log of e, which is just 1, and you're back to the other formula, which is the way it should be. So you make sure you've got that. All right, so we've derived formulas for the derivative of the basic exponential e to the x, the more general exponential a to the x, the natural log, and then log of any base, base a. We've found all four of those derivatives. You need to make sure you've got them all four in your spiral study index card, paper, whatever it is you're using to keep track of stuff to study for the exam. And make sure that you have looked at these and write down any questions. Tomorrow in class, we will look at actually practicing this with some problems and make sure you know how to use these formulas so that we can make sure we've got them down solid. Make sure you have plenty of notes and any questions written down so you can ask them.